atmosphere of the International Space Station into the hardware. So temperature, relative humidity, and carbon dioxide levels are all being controlled by the space station environment. And you guys have seen Veggie, probably pictures, media. The astronauts are able to grow and eat some of the produce that they have. So we do a lot of work here on what crops we might grow in Veggie in the future, and then how to grow them. So Veggie has LED lights. We've done a lot of work on LED lights, and it also has fans, because you have to move the air, right? In microgravity, there's no natural thermal buoyant convection, right? Heat doesn't rise. You see the candle in space, on Earth, the candle flame is pointy and it's golden. In space, it's a little ball, because there's no convective air movement to supply new air. So Lucy Poulet is a postdoc here, and she's actually looking at figuring out what the minimum airflow rate that is needed for plants in microgravity is. So she can talk with you a little bit more about what she's doing right now and what she's doing here.
So, hi everybody.
Gather around.
I'll pass around the stickers. So as Grace said, we are looking at gas exchange things. So gas exchange is what happens when photosynthesis happens at the leaf surface. You have the plant absorbing CO2 and rejecting oxygen and water vapor. This instrument here enables us to measure the CO2 absorption rate and the water vapor that is transpired. We can adjust the environmental parameters inside, so the lights, we can adjust the air temperature, the humidity, the CO2 level, and the airflow. And so when we modify the airflow above the leaf surface, we are going to see different absorption rates, and that's what we are going to see here. If you come closer when you pass by, you'll see here on this monitor we have graphs of absorption rate in real time of what's happening right now on these pepper leaves. And you can take pictures of that, no problem.
So we need to understand how plants respond to all of these different environmental variables. The Kennedy Space Center has been doing this plant research for more than 30 years. We started with some small spaceflight hardware, and some of this stuff over here is kind of old spaceflight hardware. Plants were growing in really small chambers. We had small crop chambers that would hold maybe a small canopy of plants. And we also did a lot of work on the ground in big chambers. This is actually a scale model of a former mercury hypobaric test chamber that was converted into a 2-story vertical farming facility. And this was out in our facility on the Air Force Base side. We did all the studies to figure out how much oxygen would the crops produce, how much CO2 would they use, and how much food you get from a given volume of crops. To be able to figure out, well, can we grow all food for people? Which, yeah, we probably could on a Mars base or a Jupiter base. We have a lot of space. But in the near term, we're focusing on salad crops and just picking and eating those crops directly. It takes a lot of processing equipment to process wheat or soybeans for food, and that's a lot of stuff that we would have to ship. So right now we're looking at supplementing the packaged diet, and Ralph's going to talk with you a little bit more about that when we go next door. We're looking at crops and how well they grow. We want very compact crops, but we also want things that are very nutritious, very productive, and it's enough to be seen. So we'll walk around a little bit and look at some of these chambers. I didn't even introduce myself. I'm Joy Massa. I'm a scientist here. We have some of our other scientists around who will talk to you. So this chamber is doing studies with dwarf tomato plants. So these tomato plants don't get too much bigger than that. They get about this tall. And these seeds have been subjected to simulated space radiation. Okay? The Brookhaven National Laboratory has the NASA space radiation simulation capabilities. And so these seeds have been brought there and subjected to simulated galactic cosmic radiation or simulated solar particle events. So that's the best way we can on Earth simulate what we expect the seeds and the astronauts to experience on their way to Mars. But when we have simulate the radiation and then grow the plants and see how well they grow. So you can see, you know, tomato plant growing in here. So just want to come in here, hold that door open, and peek in there. And then when you guys are done, we'll move on down. Yeah, in general, you know, and so our scientists will be looking for different anomalies to see what may have happened to them. In this chamber here, in these two chambers, we're doing new crop testing. So a lot of the work that we do here is testing new crops to develop better crops for space flight. These are tomatoes and peppers, and you'll see here a wide variety of different sizes of the peppers, right? So again, we want things that are compact. Not a lot of space to grow plants in space. So we want compact plants. We look at their yield. We'll send those fruit off to Johnson Space Center where they have the food lab, and that's where they're going to do the organoleptic analysis and the taste testing. Okay? We've been doing new crop testing for a while now and trying to get a bigger and bigger candidate slate of crops that will grow under spaceflight conditions. And we've also been working with the Fairchild Tropical Parent Garden in Miami. They have a program called Growing Beyond Earth, and you can follow it on Twitter at Grow Beyond Earth, where they have over 180 schools, middle schools and high schools, selecting crops and testing horticultural practices and feeding all those data to us. So we're getting the data of this army of researchers, and then the best candidate crops, we use statistics, they do statistics, the best candidates then get tried out in our situation, and now we actually have two on the International Space Station that were selected by these middle school and high school students. So it's really great if you know any teachers, or you know, if you are a teacher and you're interested in getting involved with this program, you can contact Fairchild and get involved with this program. But you'll see there's a wide variety in how the plants grow and how productive they are. One other thing before we leave, so Daphne, who's working with Lucy, is one of our current NASA interns. Jess and Jacob are former interns that are now working as scientists here. We have internship opportunities for undergraduate and graduate students every semester in our area through the normal NASA internships. And you know, we really welcome all different types of people with different backgrounds because we need that diversity of you to help us to create a really good program and solve some of these problems. So I think we've got a few minutes, and Jacob's going to talk about water delivery. We've got about 3 minutes before we need to change.
That's perfect. Right on. Hi everybody, my name is Jacob Torres. Like Joya was saying, I was a NIFS intern, a student intern for 2 semesters, and just recently I became a scientist full-time. But one of the experiments that I'm working on is water delivery, and if you guys want to walk on down here, we can check it out. So one of our challenges with growing crops and plants in space, and we didn't know until we got there, was the plant's roots, they actually breathe. They need air. You know, here on Earth, there's gravity. Come on over. Here on Earth, there's gravity. We don't notice that when water goes into the soil, it actually pulls air out into it, and then the roots breathe. In space, water and air mix very differently. And I think it was astronaut Scott Kelly who got a washcloth full of water, and he wrung them out, and the water formed around his hands. The same thing's happening to our plant's roots, and they're kind of like getting drowned out. They're not able to breathe. So one of our worst nightmares is imagining an astronaut eating some of our food, some of the plants that we've grown, and then getting food poisoning because of something that we've eaten. So we're like, okay, we need to solve this nutrient delivery problem. So what we did, and what I did as part of as an intern, was we set up an experiment, and we got 3 different water delivery systems for microgravity, and we're comparing them against a nutrient delivery system that's great on Earth, which is hydroponics or NFT. So in here we have 3 different systems. One of them is the APH, which is currently on the space station. Another one is the porous tube nutrient delivery system. It uses a porous tube, and it delivers just enough water for the plant to grow. And then, of course, energy and everything that you have in space, we launch up there. So whatever we have, we want to use it wisely as best as you can. So we made an on-demand system that uses automation and sensors. When that sensor, the moisture sensor, gets to be too dry, it commands the water to turn on, and that way we save water consumption with our systems. So compared to the NFT system, which uses 3 to 5 liters of water per day, the on-demand system uses 3 to 5 per week. which is really cool, and it's a big energy conservation thing. So we use our control as outrageous red lettuce, and we do 10 plants per system, because 10 is the perfect bell curve, or it's a good sample rate, and we compare the size and the biomass of the plants of the different microgravity systems to the actual NFT system. And then we use automation and different things to make them grow. Now, have you guys gone to Greenworks yet, or is that your next stop?
Yeah,
Okay, your next stop. I'm going to show you a little something. It's not on right now, but just so you can say you saw it. When you go over there, Ralph is going to explain to you our path or our mission, what we want to do. And eventually, we want to go to Mars, right? And so right now, we're growing here in our chamber room, and then we're going up to the space station. We're learning how to grow in microgravity. Eventually, we want to do a moon station, and the moon is our gateway. That's the gateway to the rest of the solar system. In about 5 to 7 years from now, there will be a moon station, which will be in a halo orbit around the moon, and they've given us a plant growth space. So they say, hey, we're going to give you this much plant growth space. Scientists, what are your scientific requirements? What is the lighting that you need? What kind of water do you need? How much space do you need? So this is the beginning of it. We're doing an experiment with different light gradients, and we're trying to find out how much light we have to give plants. Well, they'll grow well enough without using too much energy, if that makes sense.
Yeah.
So 5 to 7 years from now, when you hear about plants growing on the moon station, you can say you were here at the very beginning of it. This is it. We're getting it started right now, and that's it right behind us. So it's totally cool. I'm in between plants right now, or grow experiments. We're in between at the moment, but today we'll start ramping it up, and then on Monday we'll start planting again, and it looks really cool. And so, but for the couple seconds that I have you, do you have any questions for me at all?
Those LED lights that you use?
They are. They can be controlled. The frequencies can be controlled, so they have like light recipes, and so we can change the red, blue spectrums or whatever we wanted to do light experiments and stuff. But thank you for visiting us. We appreciate you very much, and have a good trip.
Thank you.
Take care.